Yeah, and we're live. You can start.
Good evening, hackers and guests. ISAVIT is back with another exciting keynote session in iHack 21 by Mr. Bardhan Mishra, who will be giving an introduction to cloud computing with AWS. He has experience in development, analysis, and content writing with particular expertise in web, machine learning, and cloud technologies. He has also been a project administrator at Student Code in Contributors Hack, Peak Love Summer of Code 20, and many more. We are truly honored to have you here, sir, and hope all participants will learn a lot from this session.
Good evening, everyone. I hope I'm audible to everyone in the stream. So, thanks for joining us for this session on Introduction to Cloud Computing with AWS. And in this session, we will discuss what cloud computing is in general and what Amazon Web Services is in particular. And if you are a beginner, we will be exploring all the ways that you can get started with Amazon Web Services and how you can become a cloud developer at the best. So the very first thing that you guys might be thinking is, why is cloud so necessary after all? And why are so many people actually talking about it? The first reason that I can simply think of is that the cloud and the DevOps engineers are simply one of the highest paid engineers in the IT sector today. The second reason I can possibly think of is that the cloud allows the companies to shape the market share and expand their businesses more aggressively. So, if you are running a business or you have a service that needs to reach the maximum number of people, cloud is the best thing that you can rely upon. And this is not just for scaling your application or reaching out to more and more users. You can leverage a variety of tools and software that are provided by these cloud service providers so that you can innovate and launch new products. In this session, we will basically discuss about Amazon Web Services and how you can get started with this and how you can simply launch your career into cloud computing with AWS. It will be a part theory and a part practical session so that you get a better understanding of the things right from the very scratch. If you have any doubts, any questions, just put it on the comments. I will surely take a look at it during regular intervals and I will help you clear up all your doubts. So let's get started. So let me start off with a gentle introduction to myself. My name is Harsh, and right now I'm a third year engineering student from Satyabhama Institute of Science and Technology. If you're hearing from VIT, I guess my college is very near to yours because it is in Chennai. Apart from that, right now I'm working at Red Hat as an intern, and I'm also a Google Season of Docs intern at Moja Global, where I basically contribute to the documentation, the development of the open source organization. I'm also an incoming intern at Blockchain Commons, and I have been an open source contributor at various open source communities like AWS, Google, Uber. And on the community side, I am the country head at Script Foundation. So that's pretty much about me. It would be great if all of you can just drop the place or the college that you're hailing from so that we can actually get to see the diversity of the participants here. So just drop the location or the college of yours. And if possible, drop one line on why you're actually interested in cloud computing. This is going to be sort of an interactive session, not something one-sided, but actually two-sided. So it would be great if all of you can just drop just one line about your college or your interest. Anything would be fine. Okay, that's great. Prishta is from VIT Vellore. That's awesome. And what about the others? Okay, I see a lot of highs and hellos, but I don't see a lot of people. Okay, VIT Vellore. That's awesome. Vellore. Okay. So I guess most of you are from VIT Vellore. So that's pretty great. Okay. Awesome. So let's go ahead with the next slide. And talking about my experiences with the cloud, I have been using cloud for past 1 year. what I basically worked with cloud platforms like AWS, Azure, and Google Cloud Platform. Um, Mostly, I work with Amazon Web Services because of the reliability factor. And I have worked with a dozen of services all across AWS. And if I talk about my first experience with AWS, it was during one of my internships where I had to basically manage and scale an entire application that was being used by the employees of that particular company. And it was sort of my first experience with AWS, but the whole concept of having multiple services for multiple needs and requirements simply eased my whole process up. So if I talk about AWS, then I can get a service called S3 where I can basically store my data. I can use a service called Elastic Compute Cloud, otherwise known as EC2, to deploy my application. I can use Beanstalk to manage my deployment and much more. So if you're already familiar with these concepts, then well and good. We will take a look at the demonstration at the end of this session. If not, this is going to be a very gentle ride where we will start only with the very basics before jumping into some technically advanced concepts. So without further wasting any of my time on my experience, let me help all of you to get started with your first experience in cloud. So here is the very brief agenda of today's session. So first of all, we will be getting started with an introduction to cloud computing. And secondly, we will take a look about what Amazon Web Services actually is and how AWS actually fits in the bill of a service that can actually help us allow to manage and scale our application. The third agenda would be complete practical hands-on lab. I will be demonstrating 2 hands-on lab on how you can deploy your application using AWS. And lastly, I will talk about how you can further indulge into the AWS community, like with certifications, becoming an AWS certified engineer, being a part of the AWS community as a builder, and much more. So again, if you have any question, just drop it on the chat, and I will make sure that I take a look at it at a suitable period of time. So let us jump on our first agenda. What is cloud computing after all? So before we start, let us actually take a look at how internet actually works. So as I expect that most of you already know, internet is just a more efficient and reliable way of passing data around the computers. So if you go into much technical details, internet uses a concept called packet switching so that we can move the data around. And with packet switching, a piece of data is basically broken down into smaller chunks called packets. These packets are then transferred through several routes, and then they are basically reassembled. That makes internet a very reliable and efficient way to send your data all across the network. Now, as you might know, if you have studied networking, the whole internet is running not just on one monolithic protocol. There are multiple such protocols that tie up together, which we basically call as TCP/IP suite. So if you have studied networking before, I hope most of you might have not, but if you have, then you might have known about the 4 layers of the internet protocol. And these application layer protocols are embedded into your computer. So in very layman terms, these protocols allow you to move the data to a specific device, to a specific application, and we denote them as IP addresses and the port numbers. So this is pretty much the most abstract explanation of the internet that I can give you right now, because we would be needing some of these parts in the later part of this whole session. So just like this, we communicate on the internet through various protocols and with the blessings of the internet service provider. So whatever data we fetch over the internet is stored in a server inside some sort of a data center. A server can be just thought of as a computer whose job is to provide us with the content whenever it is requested. So we have either satellite communications, we have optical fibers, so that we can actually transmit the information. But how do we actually do that? So this is basically done through the IP addresses, and these IP addresses correspond to some sort of a domain name. So every time the user enters a domain name, let's say www.google.com in the browser looks up for the IP address corresponding to that domain name in the domain name service server. And once that is done, this request is then forwarded to the data center, or let us say the respective server of the data center. And once the request reaches the server, the data starts flowing in form of light pulses through the optical fibers. So this is pretty much how internet works. But it is also the most simplistic example that you might find before you jump into cloud development. Now, we need to understand one particular thing. If you want to get some information from the internet, you need to ping the server every time. But what would happen if there are a lot of users and there are not enough servers to basically handle all of them? What would you be doing in this case? So this is where we come across a problem which we call as C10K. Basically, C10K problem states that we need to have a server that can handle 10,000 requests concurrently. And let me tell you that this was a time when web was very, very small and the servers were simply not designed to handle such a large incoming traffic. Now, with multiprocessing and multi-threading concepts, a solution was engineered, but the new problem was C10M, which speaks on handling like almost 10 million requests at a single time. This is obviously beyond the reach of large companies to create such data centers and set up servers for their needs, because that would simply come off with a very large infrastructure and maintenance cost. And this is not just the end. Popular services go down during the time of need. Let me take the example of the COVID portal. Once the vaccination portal started at 4 p.m. IST, literally everyone started pinging the server and the whole service went down. So this is pretty much one good example to see like how even governments cannot scale their internet services to a lot of users. Other examples are like CBSE result portal or the very recent TCS national qualifier test, which don't seem to have anything like load balancers or containerization or orchestration to handle the large incoming traffic for you. Because the very reason why companies cannot do it is because it is quite hard for them to configure a lot of things. And we can just simply forget about startups or private ventures altogether. So what is the problem to this particular solution, to this particular problem after all? What is the solution to it? And yes, as you might have guessed it, it is cloud. So let us first go back and explore all the problems that we had when we were starting up with the traditional server computing. The first problem was that we cannot automatically scale our services without adding more servers, because after all, more servers means more cost. Then you need then basically you need extra space for storing all sort of your data, and that would again incur some specific cost, a lot of cost, and we are not that rich to basically pay off all our bills. Again, you're also tensed about the security of your data, because if you're storing it physically, either in your home or let us say some private data center, it can be lost due to some physical happenings. Let us say like fire, earthquake, cybersecurity attack. There are a lot of options. So we have all these problems right now. We have the problem of data security. We have the problem of scaling the servers. We have the problem of extra space. But how does cloud come ahead to solve all of them simply like a magic bullet? This is the question that we have. So let us break down all our problems into multiple steps. The first step of developing any application, literally any application, is actually coding it out. No matter if you're developing a web application or a mobile application or a system application, you need some sort of a physical device to work on. Basically, you code day in and day out, and at the end, you have an application or a service running on your local machine. Let us say that it is an application to show you the weather of a place. Now that you have developed this application, you need to deploy it somewhere so that anyone around the world can simply use it up. So in the olden days, if you need to deploy your application, you might need to buy a server. If you might have seen the popular movie, The Social Network, and in this movie, basically the whole journey of Facebook becoming a company is chronicled, you might take a look that Mark Zuckerberg had to actually buy a lot of Linux servers to set his social network up and running against the heavy demand. And literally saying, buying a server is all about pain. You need to get a physical thing in your house at some cost. You need to pay for it. You need to pay for the maintenance. You need to pay for the cost. And the whole cycle repeats all over again. This is always a tedious procedure, and you almost need to think twice before you would like to scale up. But we have a solution for this now. Why don't we use cloud? In very, very layman terms, cloud simply means that we are using someone else's computer that you can rent remotely and you can access it through the internet. Cloud servers are located in data centers all around the world. And cloud basically allows the users to access the same files and applications from almost any device from anywhere in the world, as the storage and the computing takes place in these data centers. So, what exact problem does it solve for us? The first problem, you don't need to buy any physical servers now. The second problem, you don't need to keep a separate room for your servers. You don't need to pay for them either. You don't need to pay for their maintenance. You can just buy some cloud servers and you can pay for them as you simply go ahead with your application. Sounds interesting? Well, definitely it is. So, in the literal definition, cloud computing refers to renting the resources. It can be compute power, it can be some storage space, it can be just someone else's computer. Like, let me just take a very good example. Let us say that you're doing a machine learning experiment and you need a GPU for that. And of course, buying a GPU is literally expensive and your own laptop doesn't have a GPU. So what will you do in that case? You simply rent someone else's computer on cloud in the literal sense, and you can just do your experiment over there. So how do we get such sort of compute power or storage space from these cloud computing companies? So basically, the companies that are providing these services is referred to as a cloud provider. And there are literally tons of companies that are providing cloud services right now. Some good examples are Amazon Web Services. We are going to discuss about it today. We have got Azure, we have got Alibaba, we have got Oracle, we have got DigitalOcean, we have got Linode. There are a lot of options right now. Basically, the cloud provider is responsible for the maintenance of the physical hardware that is required to execute your work and to keep it up to date. This makes cloud computing an extremely profitable avenue, especially with respect to the deployment of your application. The best part about cloud is that now you can scale your applications automatically and you can just pay a fraction of the money that you have to pay previously. And also you can get access to a lot of services that varies with this service provider. So one of the best things about cloud computing is that it is not an all or nothing approach. Companies can choose to use cloud resources as much or as little as necessary to fulfill their needs. Cloud computing also provides a pay as you go model, which means that you only have to pay for the resources that you're actually using. You do not need to buy any hardware, you do not need to buy any infrastructure, and you can stop paying for the resources that are no longer needed. You can increase or decrease the resources and services at any given time according to your needs. So all of these advantages cannot be provided if you're using some sort of a local computer or a local server. With cloud computing, you can achieve data redundancy, you can achieve fault tolerance. The whole cloud hardware will be maintained and it will be upgraded by the cloud service provider, not by you. And the cloud computing system can simply compensate for the workload charges. So if your service is scaling up or if it is scaling down, you can automatically add or remove resources as per your convenience. This is all the advantages that cloud computing can provide you as of now. And now that you have understood what cloud actually means and why is it so relevant for us, why don't we discuss about Amazon Web Services? Because after all, it is the most popular cloud service provider in existence. And it can be sort of an understatement, but I would really say that AWS is really one of the greatest inventions in the history of mankind when we see things from a digital outlook. So if you have any questions or doubts up till now, you can simply drop it on the chat section, or else I will simply move ahead with the next agenda of the session. So do we have any questions? I'm sorry guys about this parallel reflection thing, but I just want to take a look if there are any questions coming up. Okay, I guess not. If you're pretty much clear up till this point, can I just get a simple yes on the chat section so that I can know that yes, I can simply move forward with continuing this session? Awesome. Cool. So I guess we have a few yes. So let's move ahead and explore AWS in pretty much depth right now. So why is everyone literally so excited with AWS? Let me take an example here. I hope most of you have played this game at some point of your school life or your college life. If you have not, then you are pretty lucky or unlucky, I would say. But if you have, then I guess you pretty much know about this game. For people who don't, this game is like called Players Unknown Battleground, PUBG, in the short form. And this game was literally a craze once in India, and not just in India, but also in other parts of the world. So a first-person shooter game where you're basically pitted against multiple participants, and it is a game that everyone will cherish and everyone will enjoy. But if you take a look at the things from a developer perspective, things will simply not look so good after all. So let us explore some technical difficulties that might go inside into creating such sort of applications that literally have a craze right now. So let us say that you're making a first person shooter game or any sort of a game that you're expecting to blow up. Means once you launch it into the market or the Play Store or the App Store, people are going to use it. They are going to play it to the death and they are going to simply enjoy it. So as a developer of the game, you have coded out the whole game or the application, and now you're estimating that almost 1,000 people will be playing this game in the very first month. So what do? Basically, you buy a hardware, like setting up some server, you set up some configurations, you deploy your application over there, and now you're pretty much ready to launch the game. You're pretty much ready that people are going to use it and they're going to simply enjoy this game. But as soon as you put this game over the Play Store or the App Store, this whole application becomes viral. Literally everyone is playing it. People are sharing their live streams over YouTube. They are posting about it on Facebook, Instagram, or Twitter. And now more and more people have started downloading your game. They're starting to play it and they're starting to enjoy your whole creation. But now you have faced a serious technical difficulty right now. And the technical difficulty is that the expected downloads have just gone over 100x. Means that you just bought a server for serving only 1,000 users, and now literally 100 times more users are using it. So how exactly can you tackle such a technical difficulty? This is a real question that we need to address. So it turns out that we have actually two solutions for this. The first solution is pretty much how the traditional server computing goes like. At first, you just buy more and more hardware. You buy more and more hardware so that you can set up your servers on top of them, in the view that all of your servers can meet the increasing demand. And eventually you have to pay for the servers, you have to pay for their maintenance, you have to pay for purchasing them. And at the end of the whole game, the cost of setting up and maintaining these servers will simply exceed the amount of the profit that you're getting out of this game. But we have a second solution as of now. And the second solution is very, very simple. And it is just use cloud. So basically, cloud provides us a lot of advantages. The first advantage is instead of paying more and more hardware, instead of like buying for it, instead of maintaining it, you can just rent some of the resources from some sort of a cloud service provider, and you can easily scale up the amount of the hardware that you need by specifying the cloud service provider. So let us say that my service is being set up on, like, let's say 10 servers as of now, and I'm literally expecting 1,000 more people to join my application. So I can just scale up my application and I can let the other people access my application and use it up. If my application's popularity is going down, like let us say one server is like, let us say 10 servers is handling like 10,000 people, and now only 7,000 people are using it, I can just remove those servers from my cloud service provider, and I can simply focus my time and efforts only on managing those servers that I'm literally using right now. So this makes the whole thing pretty much flexible, and we don't need to worry about it a lot if you're using it. The second benefit is that it is simply pay as you go. So you don't have to pay for buying the server or managing it or configuring it. You just have to pay for the amount of time that you will be using this service for. So if you don't want to use this service, just terminate it and no questions will be asked to you. This simple approach simply makes the whole thing flexible, reusable, and also a lot transparent, because you don't want to waste a lot of time on configuring manual things. And the last, but the very important point, is that the uptime availability provided by these cloud service providers is like at least 99%. And this makes it fault tolerance. This gives it certain degree of flexibility. And you cannot expect this sort of availability on your own servers or on some local cloud service provider. So such rates are only provided by large cloud giants like Azure or AWS or GCP. And this is the reason why majority of the people simply want to go with these key players in the cloud computing market. So basically, like, the best part about cloud computing is that you don't have to spend so much time upon infrastructure and hiring the technical skills. Earlier, most of the businesses had to rent some space for their own data centers. They had to buy their own servers, they had to buy their own hardware, they had to hire people to manage these servers, install any upgrades, back up the data. So it was simply like managing every single tiny details themselves. And as a technical lead, as an engineering manager, just thinking about this is simply stressful, because all you want to do is to deploy your application so that people can use it. So Amazon Web Services here comes as a key player in the cloud services market. And it is surely one of the greatest inventions in the history of mankind, because it has been a building block to deploy different type of applications to the cloud. And the whole part can be justified by simply taking a look at how many startups and companies are using AWS services in real time right now. So just a bit of a history, AWS was launched back in 2006, basically to take care of the online retail operations of Amazon. As far as I remember, it started with managing some XML and SOAP services. But right now, AWS is one of the major draw cards of the cloud computing technologies. And it not just provides a cloud hosting services, it provides a whole host of services that you can use not only for deploying an application, but also for developing it. So undoubtedly, AWS is the largest and the globally renowned technology that can provide you cloud computing products and services. And it is also the most successful and profitable services around the world. So what exactly can you do with AWS? So AWS existence is so large that it can be simply divided into two main products. Let us take a look at it from the AWS Management Console itself. The first product is Elastic Compute Cloud, which we call as EC2. And the second one is called Simple Storage Service, which we call as S3. So these two services have basically allowed AWS to scale to a great magnitude, because most of the companies that you will see using AWS right now, they are compulsorily using EC2 and S3 for these services. Apart from that, AWS also provides other services like, let us say, CloudFront. Then you have got basically, so this is the CloudFront, which is like the CDN, basically a content delivery network. You have got then SQS, which is like a simple queue service. You have got SimpleDB, which is like a simple database management for your AWS things. You have also got VPC for managing your virtual private cloud so that you can basically isolate your cloud resources from the public providings. You have got relational database services. You can just call it like a MySQL-based database on the cloud. You have got DocumentDB, which is simply the AWS fork of MongoDB. So there are literally a ton of AWS services that you can use right now. And you can not only use it for remote computing, you can use it for server computing, you can use it for networking, security, storage, email, mobile development, app development, and much more. Like, let us take some examples. So if I just go to S3, then we are basically this service is called Simple Storage Service. And the main purpose of this service is to allow the users to create a data backup. And on a free tier, it can create a data backup of like, let's say 5 gigabytes. So users can store, they can organize the data, they can store them in the S3 buckets. And basically this allows you to have all your static files into one single bucket. So I have some buckets right here. There are some buckets here as well. You can just create a bucket by clicking on create bucket. And now you can simply put up your files, if they are scaling up too much, you can just put it up right here. And you need to make sure that all of them are static. They are not changing like a database. So you actually cannot use S3 for storing your database as of such. AWS also provides users to access another storage, which we call as the Glacier. So if you're managing a whole startup and you need large amount of storage, you can use Glacier, or you can simply use Elastic Block Store for your purpose. So AWS provides you a ton of services that you can basically use for all sort of things. So this is just few examples that you can use for storage. But what about deployment? So for deployment, we have got Elastic Compute Cloud, which we call as EC2 affectionately. And it is basically, okay, let me just find it here. Yeah, there it is. And basically, it is a web-based virtual server so that you can set up your application. And these servers, we call them as instances because they allow the developers to access the compute capacity on the AWS data centers. Apart from this, we have got RDS, which stands for Relational Database Services. Let me just open it right here. Okay, here it is. So this is what we call as RDS. And basically, it is compatible with a wide range of database engines that the users can use to migrate, recover, and even take the backup of their data. Apart from this, you have got VPC, so that the users can get the full control to a very isolated segment of the AWS cloud. You have got identity and access management so that you can basically assign roles to other users so that they can have the ability to create and control custom policies. You have got various SDKs, basically software development kits. You have got command line tools. Like if I just show you one command line here. So we have got the AWS CLI, which we can just use to basically control all of our AWS resources from the command line itself. AWS has literally a ton of things. And it only depends upon your imagination on how much you want to explore and how much you would like to find out about the things. And AWS is launching multiple products right now. Like I got a notification about Aurora, and it is a MySQL and PostgreSQL enterprise class database. So this is one example of how AWS is simply adding multiple services to their portfolio so that you can simply use it for your own business use case. If you have not actually started using AWS, I will definitely recommend you to go to aws.amazon.com and sign up for Amazon Web Services today. It will be asking you for a credit card so that they can basically authenticate if you're a real user. And they will be cutting a very small amount of like 1 or 2 rupees just to verify your authenticity. And once that is done, they will simply transact the amount back to your profile, and you can start using the AWS services on your own bidding. If you are a student, so you can basically make use of AWS Educate, because AWS Educate provides you a few credits, and it provides you a free tier access to multiple AWS services that you can use for your own purpose. So you can set up servers, you can set up IAM roles, you can create a VPC, and all of this will be simply managed by the amount of bill that you have in your educate, and you will not be penalized a single thing. If you are on GitHub, then you can simply apply for GitHub Student Developer Pack. I hope most of you have already applied to it, but if you have not, do apply for it. And with that, you can also get a credits of like $100 or $150, depending upon your profile. I don't remember about that because it was almost a year back since I accessed that service. So yeah, let's jump back. So you can use AWS through a lot of interfaces. The most popular one is the web user interface that I showed you right here, that we're going to use today for a practical demonstration. AWS also provides you a command line interface that I showed you right here, so that you can manage all your services without leaving your terminal at all. Apart from that, you have got AWS SDKs, so that you can develop your application using those SDKs. Okay. So yeah. So you have got these SDKs and the programming toolkits on AWS. You can go with C++, you can go with JavaScript, you can go with Node.js, Python, Ruby, whatever is suiting you depending upon your preference. We also have got some third-party services, basically some packages and all that you can basically use as an abstraction over AWS services in an easy manner. Lastly, if you are a machine learning developer, if you would like to work with robotics, machine learning, computer vision, artificial intelligence, AWS has services even for that. Like if I go to recognition, then it basically allows you to add visual analysis to your application. Lex allows you to create conversational interfaces. You can use EMR for, basically creating a big data application, which is on a managed Hadoop framework. And this is just to name a few. So why should you use AWS after all? Why not some other cloud service provider like Azure or GCP? The first reason is because AWS is designed to allow application providers, vendors, startups to quickly and securely host their application. And it can be an existing application, it can be a SaaS, it can be a mobile application, it can be anything. You can just use the management console right here. You can use a documentation, you can leverage the community that is behind AWS so that you can manage the development and the deployment in a very convenient manner. Apart from that, AWS enables you to select the operating system, programming languages, web application platform, database, and the other services that you simply need. With AWS, you can get a virtual environment so that you can load the software and the services that your application requires. This eases the whole migration process, and you only pay for the compute power, storage, and the other resources that you're using, with no long-term contracts or no upfront commitments. You can use a ton of AWS tools like auto scaling, elastic load balancing, and much more so that you can scale up or down depending on the demand of your application. So in very short, since AWS is backed by the Amazon's massive infrastructure, you can get access to compute and storage resources whenever you need them. So now that we have come this far, I guess you have actually taken a look at how AWS looks like. So I don't need to go over this slide all over again. But if you have not, this is already the AWS Management Console. AWS documentation, it is a bittersweet. So most of the people find the documentation really okayish. But if you don't find the documentation really intuitive, you can just go over to the AWS community, and there are literally a ton of people. They can be AWS heroes, they can be AWS community builders that would be more than happy to help you out in setting up your AWS service. But apart from that, AWS offers you a ton of training, ton of tutorials. Like we have got some few tutorials like launching a virtual machine, building a web app, start migrating to AWS and all. And you have got some fundamental aspects as well that you can simply pick up, and you can use them to learn more and more about AWS. So this brings us to our third agenda, which will be a practical demonstration. And in this practical demonstration, I will show two of the AWS services that I personally use a lot so that I can just explain the basic intuition behind them. Up till now, if anyone has got any questions, I would love to have them on the chat section below. So come on, guys, if you have any questions, just drop it on the chat. Or otherwise, I will get started with the practical demonstration. It will be very simple. It will be sassy, and it will basically help you get started with AWS in a really fun manner, depending upon your preferences after all. Okay, I guess we don't have a lot of questions. So if not, let's get started with our actual live deployment so that I can share some of the services and how you can exactly use them up. So what are the labs that we will be doing today? So we have simply two labs that we can use to demonstrate on how to deploy your applications on AWS. And both of these labs will be on the free tier resources. So don't exactly worry if you have not logged into AWS. You can simply take a look at my steps, and possibly once you have your AWS account, you can revisit the same session and you can take a look on how I was actually doing it. So we will be doing two labs today. The first one is that we will be setting up a live server. It will be on Elastic Compute Cloud. And we will then set up an Nginx reverse proxy server. I will explain on what a reverse proxy is, how you can actually access the remote server from your local machine, and what AMIs are in this very short demonstration. And in the last part, I will be showing you on how you can deploy your portfolio site using React.js through AWS Amplify. And for people who are not familiar with Amplify, Amplify is just the AWS version of Firebase. And if you're not familiar with Firebase, then basically both Amplify and Firebase are serverless frameworks on Google Cloud and AWS respectively. But I will show on how Amplify goes a step ahead compared to Firebase and makes the deployment real easy for us. So let us first get started with launching a virtual machine, basically our own server. And it will be on an Ubuntu operating system. We will set it up. We will try to access it locally from our machine. And then we will set up a reverse proxy server so that we can actually start developing and deploying our application over there. So let us get started with EC2. So you can just go to the Management Console and you can click on EC2. So Elastic Compute Cloud is basically Amazon's primary web service that gives you resizable compute services in the cloud itself. But now you might ask, on how are they exactly resizable? So they are resizable because you can quickly scale up or scale down the number of server instances that you are using if your computing requirements change. So if I'm using 10 servers right now, 10 instances right now, I can simply scale them up or down depending upon my requirements. No questions asked to it. Instance is a virtual server so that we can use them to run our applications on EC2. Giving an analogy, you can just simply understand it as part of a large computer, as part of a tiny part of its own hard drive or a network connection or an operating system, but it is all virtual. So you can basically have multiple such tiny computers on a single physical machine, and all these tiny machines are called instances. Let us check it on our own AWS Web Console. So this is how the EC2 dashboard actually looks like. So I can get to see how many instances are running. I don't have any instances running on my own personal profile because of the preferences. So why don't we simply launch an instance? So let's do it. So first, what we are going to do is that we are going to get right here, and we are going to just click on the launch instance, and then we are just going to click on launch instance. As soon as we click on launch instance, we will land upon a wizard, and this wizard would be our guiding light towards creating our very first virtual machine. So as you can see, we have got 7 steps right here. So first we have to choose an AMI. Then we have to choose an instance type. Then we have to configure that instance. We have to add storage to it. We have to add some tags to it, configure the security group, review all of them. And then with just one click, we have our own virtual machine on the cloud right now. So let us first get started with choosing our own instance, basically our AMI. So as it is explained here, AMI is just a template. So if you're not actually following an AMI, you're going with a bare bones server, you have to configure literally each and everything from the very scratch, with the operating system to the package manager to the languages. It is literally a ton of mess that you have to deal through. So why should we deal with this mess when we can simply use an AMI for our purpose? So as you can see, AWS provides you a lot of AMIs. We can also create our own AMIs. We can go to the AWS marketplace for getting these AMIs. We can also take a look at the community AMIs. And you can also check out your operating system depending on what AMI you require. So if I just check out Ubuntu, we have got these AMIs right here. If you want Windows, then you have got AMIs for that as well. If you want, let's say Amazon Linux is being maintained by AWS itself, so you can basically request for a lot more reliability to it. So you can expect a reliability to this factor. So you can choose all of the AMIs that you can use. But right now we are just looking to get quickly started, and I don't really want to spin up a very large server that is going beyond my budget. So I will take a look at all these AMIs, and if you see one thing, let me just maximize it. So these AMIs are basically free tier eligible. Free tier in the sense that I can simply launch these AMIs. I can work whatever I want to do. And basically, I don't need to pay anything for running these AMIs for the upcoming 12 months. So this is an advantage that is provided by AWS for our use case. So let us check out an AMI that we are going to use today. So it turns out that we are going to use the Ubuntu Server AMI, and it is free tier eligible. It is 20.04 LTS. So let us choose this up. So we can just go and just click on the select. With this option, you can also specify the processor architecture that you want to use. You can use either the 86 architecture, you can use ARM, your choice. I'm going with 86 one. Once you do that, you have to specify the instance type. And basically, AWS has got instance type for each and every virtual machine. So do you want to go with nano? Do you want to go with micro? Do you want to go with small? Or do you want to simply have a very large virtual machine for yourself? So there are options for that as well, as you can see right here. But again, I don't want any sort of a bell. So I will just go with this T2 micro because I just want to show you one basic demonstration, and it would simply suffice for that. Let me just click on configure the instance details. So now we can specify the number of instances. I can either have 1 or 2 or 10 or 20 or 100, my choice. But I'm just going with 1 because after all, it is a demonstration. Then we can specify the VPC, basically the virtual private network. The virtual private cloud. But I don't have a VPC on my own personal account, so I'm not going to use that. So we don't have anything as of such on this particular wizard, so let us go ahead. Now you can add the storage. Either it can be 8 gigabytes, it can be 16 gigabytes, it can be 32 gigabytes, or it can be 2 gigabytes. It is all your choice. But again, I'm going with the default one. So let's go with the tags thing. Here you can simply add the tags. So the tag can look something like this: VIT demo AWS EC2. And this is how you can simply take a look at all your tags. You can make sure that if you have multiple instances up and running, you can simply make sure that all of them are better managed by using these tags. And lastly, the most important one, you have to configure your security group. So security group basically specifies the firewall of the EC2 instance on what sort of services can actually use your AWS EC2. So right here, we have the secure shell access. So secure shell access, in the simple meaning, it means that we can basically make use of it to authenticate the EC2 instance from our own local machine. So let us keep it as it is. But let us add an instance so that we can actually make sure that if we're deploying any sort of a web application on top of it, we can access it up. So let us go and select HTTP, which basically stands for Hypertext Transfer Protocol. We are going to use a TCP protocol here, which I explained before. So we can specify the source and it can be anywhere. So people from all around the world can specify the IP address and they can access my EC2 instance or whatever is deployed on it. And I can just add a description on top of it. But this is really optional. Once everything is pretty much configured, let us go on review and launch. Here you can take a look at the entire thing, your entire instance. So I can see that it is an Ubuntu server. It is free tier eligible. It is a micro instance. These are our security groups through which we will be accessing the application. These are our instance details. This is our storage details, everything. And once everything is done, let us click on launch. Here we can actually choose a key pair. So if you're not already familiar with key pairs, then EC2 basically makes use of public key cryptography so that we can encrypt and decrypt the login information. So public key cryptography, it basically makes use of a public key so that it can encrypt a piece of data like a password, and then the recipient can make use of a private key so that it can decrypt the data. This combination of public and the private key is what we call as a key pair. So we have to create a new key pair here, and basically this public key will store consist of what the AWS store, and the private key will consist of what we will store. So this public key would be stored on the AWS instance, and the private key will be stored with us. And we can basically make use of these public and the private key to authenticate ourselves into that virtual machine so that we can securely SSH to the instance without using any sort of a ID or password as of that. So let us create a new key pair. Let us name it VIT AWS, and we can simply download the key pair. So as you can see, once I downloaded the key pair, I have the PEM file right here, and I need to make sure that it is not accessible by anyone else. So what I'm going to do is that I'm just going to chmod it. So basically it will be read only so that it cannot be accessed by any third-party service. And that will make sure that my entire private key is secured. If you do not follow this step, then AWS will fail to authenticate with your own EC2 instance. And we simply don't want that. So once we have downloaded it, launch the instance. And do remember, once you download the keys, do not delete it. Just keep it safe and sound at a particular location. And you are going to use it to basically SSH into your instance every time you need to access it. So once that is done, I can go and take a look at my instances. And as I can see, within a few clicks, a few seconds, our instance has been launched right here. So I can click on this instance. I can take a look at all the settings right here. So it is an Ubuntu, okay? We have got this public IPv4 address, a DNS, a private address or a private DNS. We can take a look at the details, the security, the networking, and you can also edit it as per your convenience. If you have missed something out during the creation process, you can edit it right now. But what we actually need right here is that we need to set up a connection to this EC2 instance from our own local machine. So let us go to instances. Let us right click it and let us click on connect. As soon as we click on connect, we get to see three options through which we can access this EC2 instance. The first one is by using an instance connect. The second one is by using an SSH session manager. But the most reliable one, and this is what the most people use, is an SSH client. So basically, I'm using my terminal here as an SSH client. If you're on a Windows operating system, you can make use of putty, or you can also make use of the git bash as your SSH client. And what I will be doing right here is that I will be just locating my private key file, which is stored right here. And I've already made it only read-only. It is not publicly viewable by using this particular command beforehand. But what I'm going to do right now is to basically SSH into this instance. So this is the command that I'm going to use, and it is the public IP address. And this is my private key pair, and this is what we are going to use. So let us click on it. Let us go to our terminal. And let us paste this all. As soon as we paste it, it will ask if we want to authenticate this particular host. And do I want to connecting? So of course I want it because I need to show a demonstration. So I will just write yes. And it will add this particular host to my operating system. And now I can simply start using this EC2 instance. As you can see that I have accessed this instance and it is running on an Ubuntu virtual machine right now. So I have a Red Hat Enterprise Linux, but now I can work on an Ubuntu operating system right from my terminal. So let me clear this up. And now you can simply use all sort of commands. So let me just update it all. So sudo apt update, and it will start the whole update process. And it will give you a complete Ubuntu feel without having the graphical user interface. But now what we actually need to set up right here is a reverse proxy server. Now the first question that you might be asking on what is a reverse proxy server? So let us take an example. So if the users are creating out any sort of an activity on the web, then these requests make a route to a server or a cluster of servers that are hosted remotely. And if it is having a prolonged response time or a service unavailability, it can be a bad user experience. Let us take the example of Instagram. Instagram has over almost a billion users, if I'm not wrong. I might be, but let us say that if it has a billion users, and if all of the users are trying to post something by pinging a single server, that can create a whole lot of mess. Because after all, this would result in the overloading the server's computing resources like the CPU, the RAM, and it will eventually lead to a delayed response, or in the worst case, the whole server might crash. Now, this is where the concept of load balancing comes into play. We basically have got these load balancers. It can be software or hardware load balancers. And we can use these load balancers to basically distribute the workload across multiple servers that are hosted around the world. In a similar case, we will be using Nginx as a load balancer. Nginx is a very high performance, it is highly scalable, it is highly available web service that basically allows us to implement a reverse proxy server, a web accelerator, so that we can get a load balancer, a content cache, and even more through one single service. So let us take a look on how we can actually configure an Nginx server. So the first thing that we are going to do is that we are going to use the Ubuntu's package manager apt to basically install Nginx. And once that is done, it will automatically start the whole installation thing. It is lightning fast because after all, it is on cloud. It is not on my own Wi-Fi network. And once that's done, I can simply take a look at the status of my Nginx. So as you can see, my Nginx is active, but I simply cannot access it as long as I don't allow the firewall to basically open up the Nginx port on the hypertext transfer protocol. So what I'm going to do right here is sudo ufw, which will specify to the firewall of the Ubuntu. Now we just type in allow nginx http. And once we do that, it will automatically update the rules. And if we run the command again, we now see that our Nginx is completely running up and fine. And now we can start with developing and deploying our applications on this particular reverse proxy server. So if I go back to my instance right here, so after a few minutes, if you just click on the public IPv4 DNS, you can actually see the basically the Nginx homepage right here, which basically demonstrates that your instance has been successfully set up. The reverse proxy server is successfully working. And now you can go ahead with deploying whatever you wish to use. It can be a PHP application, it can be a React application, it can be a Python application. It is completely your own call. But it is going to happen after a few minutes, and we don't have the time for that. But with this, you can also access a lot of other services. Like let us say that I want to get started with MySQL. So I can simply install the MySQL server, and it will automatically download everything for us on our very own local virtual machine. So this is the sort of the power that AWS provides to you to basically develop, deploy, and managing your entire full stack application, and also scale them up automatically. So this is in the progress. Let us get it completed within a few quick time. Okay, it is on 90%. But till then, let us see if someone has got any questions, any doubts. I don't see a lot of people on the comments. But yes, we have this MySQL up and running. So let us get started with the MySQL server. And now you can get started with all your MySQL commands. So I can just type in create a database. Sorry, typo. Let us keep it like example database. And now, yes, our example database is up and running. You can specify the rows, you can specify the columns, you can append the data, you can run queries. It is all your call. So with a virtual machine, you don't have to depend on the platform to basically run these type of software. And you can use these environments to basically develop and deploy your application single-handedly. And this is how you can exit it out. But let us say that you're using an instance, and after some time, the job of the instance is over. You no longer need the instance. As long as you're using a free trial, you will not be charged. But if you're using a paid service, it is always best for you to terminate the service before it sends you a very long bill. So if you want to terminate a service, just select that particular instance, go to the instance state, and just click on stop instance. As soon as you do that, automatically the whole instance will be stopped. And if I want, I can just go ahead and I can terminate this instance. Terminate in the sense that this whole instance, along with all the configuration files, all the setup will be automatically removed, and you basically cannot revoke them back at the time. So this is how you can actually set up an EC2 instance, and you can set up an Nginx on top of it. And the second lab that we would cover, it would be really very short. It would be about Amplify. So as I said before, Amplify is a serverless framework through which you can build full stack application. And it is available for JavaScript, Python, and even more. So if you want to have a managed serverless framework for developing and deploying your application with a very minimal backend, Amplify is the right choice for you. The main reason why I'm such a huge advocate of Amplify is because it ties up with a lot of AWS services. So with Amplify, you can get to access S3, you can get to access Cognito, you can get to access DynamoDB without needing a theoretical knowledge of any of these services. So this is the power that Amplify brings to you, so that you can just use one single framework for developing and deploying your application throughout. So let us actually take a look at Amplify and deploy a very simple, literally a very simple application for our use case. So as you can see that I have this particular personal portfolio. So this is what I developed almost 1.5 years back. And it is built in React.js. And it is supposed to be my personal portfolio where I put all of my information. And it is using a Bootstrap theme. And now I simply want to put it over the web. So if you're going for any standard static hosting option, you can go with Netlify, you can go with Vercel. But in this example, I'm going with Amplify, because I just want to show how easy it is for you to set up your application, your static build over Amplify, and how you can manage your entire continuous integration and continuous development over Amplify as well. So let us go to Amplify. And as you can see, I have to create a new app right here. So let me say that I want to create host and web app. And once I do that, it will ask me to choose my existing code. So Amplify integrates with a lot of cloud service providers like GitHub, Bitbucket, GitLab, even Code Commit. And we can actually deploy it without any sort of a Git provider as well. For this case, let us pick GitHub. Once we do that, we have to select the repository that we actually want to deploy. So it will take some time, but let us choose the repository. In my case, it would be my personal portfolio. Then I need to specify the branch from which I would be deploying. So in my case, it would be the master branch. And then I should click on the next. And as soon as I click on that, it will specify the build settings for me. So if you're a Node developer, you already understand some of these commands like yarn install and yarn run build, which is basically used to compile the whole application and create an optimized build so that you can basically serve it. And once I click on next, and once I click on save and deploy, it will automatically start deploying my application across an entire managed CI/CD. So it will be visible over here after a few seconds. And this is where you can exactly see the whole CI/CD pipeline up and running. So yes, this is our application. This is our public URL. And right now our application is being provisioned. So basically it is being cloned over the some sort of a virtual machine. Then it would be built. Basically all the packages would be installed. It would be run, it would be compiled, and basically a static build would be served through deploy. And lastly, with verify, we can actually take a look at how our application behaves over a host of devices. It can be smartphones, it can be tablets, it can be something else. So if I just click on provision, you can actually see the logs here so that you can get to see on how your application actually works on some sort of a production server. With build, you can exactly take a look at all the packages that are being installed right here. So yes, right now all the packages are being installed. It will take some sweet few minutes, but once that is done, it will be automatically built, it will be deployed, and it will be verified. The whole CI/CD pipeline works very simply. It means that every time you make a commit, the application would be built all over again, and it would be visible on your development or the production server. This makes Amplify simply a lucrative option for you to develop and deploy your applications. And I personally use it for developing my production applications using React or whatever front-end framework that I'm using up. If you want a very deep look over Amplify, I'm taking another session tomorrow. So maybe you can join that over so that you can actually take a look on how you can create your first Amplify application using a GraphQL backend. But this was just one demonstration right here. Let us arrive at the last agenda of this session on how you can leverage AWS further. Now that you know some of the basic services provided by AWS, how can you exactly make sure that you improve your skills in the field? So first things first, AWS is just another wheel towards creating a better product. Over the last 5 years, technology has reshaped the way we have been doing the business. Cloud computing has not only driven the cost down, it has also helped companies across industries to increase flexibility and productivity. AWS as a service simply eases the engineering needs and provides ready-made solutions to existing problems. That allows engineers to focus on their code and reliability rather than setting up servers manually or ensuring the uptime of their application. So, as a cloud engineer, your first and the foremost solution is to leverage cloud, not just for development and deployment, but also towards creating a loosely coupled service that provides better reliability, durability, and overall creates a business value towards the product. Let us have a look at the architecture here. Here is a simple architecture of a full stack app built using AWS. Like in this app, you can see that the static files are being served by the S3 bucket, and the S3 bucket is converted to serve as a website. To have a better performance on the front end, S3 bucket is selected as an origin to a CloudFront domain. And this CloudFront basically acts as a CDN, a content delivery network for the app front end, and it can provide faster access through the application. All the backend APIs are through the Lambda functions, and these Lambda functions are totally serverless. And your task is to only upload the code file so that the Lambda function can be created and deployed. To expose these Lambda functions, we are using the API gateway, which is provided by AWS. And all of these services have their own separate endpoints that is being managed by the Route 53, which provides a custom domain. We can use multiple databases here, like we can use RDS for Postgres. You can use Redis for session and cache management. You can use Elastic Search for search functionality. And all of these above points can be a good idea about how the app architecture is designed for an actual production environment with a scalable factor taken into account. In these fast-paced times, the clients basically want faster delivery of their software product so that they can stay competitive in the IT market. So basically, we make use of a methodology called DevOps, and I really hope that there was a DevOps session before this one, so that we can use it to improve the collaboration between all the stakeholders from the planning stage through delivery and automation of the delivery process. So organizations which are already using AWS have realized the importance of DevOps, and therefore they are looking to bring skilled AWS engineers to build their cloud infrastructure. And with this cloud infrastructure comes the DevOps culture among the team, and it above all creates business value for the organization and the product that they are in charge of. There are many different job roles in the DevOps and the AWS right now, and all of them provides you a very long-term professional commitments. So if you're a certified professional in AWS, you can go as a DevOps consultant, you can go as an infrastructure architect, you can go as an machine learning engineer. There are literally tons of options. And AWS, as of today, provides multiple AWS certification paths, and it totally depends upon your skill set, your area of expertise, and your years of experience. So if you're planning to become an AWS certified professional, you can maybe go with the foundation certificate. And for every higher certification, you will need to clear the very first certificate. Now, Which certificate comes the next depends upon your expertise, your years of experience, your interest. Like if you're a cloud architect, then maybe a professional solutions architect certification is good for you. If you're a machine learning engineer or you aspire to be one, you can go into some machine learning certificates like machine learning specialty and all of that. So gaining AWS certification requires a lot of experience and skill set. And if you do not have any hands-on experience, or you do not have any understanding and working knowledge of AWS, it might be difficult for you. But if you're willing to learn, if you're willing to work hard and put some efforts, it's not that difficult after all. So with this, we have arrived at the very end of this session. So thank you all for joining, and thank you for your patience to continue with this session. You can connect with me on LinkedIn and GitHub at Harsh Casper. And if you're on Twitter, you can connect with me at Harsh_Casper. And I'm completely open to questions right now. So feel free to shoot it on the chat section so that I can basically take a look and I can clear up all of your doubts. Thank you all.
Thank you so much. So the session was really detailed, and I think there are no questions. Everyone understood it.
That's great to know. But if you have any questions, just drop me a message. If you want credits on AWS, do let me know. I can provide you that as well. And if you're looking for certification, do let me know about that as well, and I can provide you some resources for that. Basically, land upon your first training voucher, or basically land upon your first certification course. I'm completely open to any communication, so feel free to reach out to me at any time.
Oh yes, sir. If you could just give your mail ID in the chat, so anyone can contact you for doubts.
Sure. I'm just dropping it right there. So if you'd like to contact me on the chat, just drop me a mail at contact@harshcasper.com. If you are on LinkedIn, just search up my name and you will find it on either your first degree or second degree connections, and you can just send me a direct message.
So we are honored that you accepted our request to give the speaker session today. It was a really enlightening session, and we surely learned a lot of interesting things. We appreciate you taking out your time and joining us today to make iHack a grand success.
Thank you all. Thank you all for joining. Hope you have a great weekend and a great hackathon.